at some unit testing and automated functional testing. This is a technical talk. There will be code examples. Any management in the room, please don't get too scared, because maybe later on in the presentation, there'll be some value for you too. Okay, who am I? I'm Alistair Stead, as Natalia has just said. I'm technical team lead at Session Digital, part of the iBuildings group. I've led projects for WMI, KUKI, amongst others, with 11 years commercial experience, and I've got a keen interest in development processes and practices, how we make our life easier to deliver better and higher quality solutions to our customers. After all, creating software is hard. Adding new features is easy and fun. Maintaining and refactoring software without breaking existing functionality is harder, and sometimes not very much fun. Okay? There are certain applications of software where fault tolerance is incredibly low. Okay? More and more in society, we rely on systems. We take them for granted. Okay? Some of those, including e-commerce, are incredibly low, have a low tolerance to faults. And thanks to Magento, they make it very obvious that something went wrong. Okay? And who's the client going to call at the end of the day? Okay? If something's broken, we need to fix it. If we've just deployed new functionality, where do we find where the bug is? How do we make sure that bug stays fixed and we don't deploy the same issue next time? And most of all, let's make sure it doesn't land on our doorstep in a couple of weeks' time. So how do we fix this? How do we ensure software is working correctly? How can we reduce the risks when we add new features that we don't break existing functionality, both to Magento core and the modules that we write? Okay? I mean, we're clever people. We study long and hard to be good at what we do, but we're busy. Okay? We don't have time to test everything every time. We only test in isolation. Again, we may fix a bug. Next week, your colleague breaks it again. Do you continue to test every week? Not really. So how can we solve this? We could just get more clever people. More clever people cost more money. Okay? So then you're going to start saying, when do we test? Do we test with this many people after every code change? I think not. Do we test at the 11th hour, just before deployment? If that's the case, when do we have the time to fix those bugs? So let's start and leverage some technology. Let's use technology what it's good at, which is doing the same task repeatedly and testing for the same outcome, because that's what software should do. Okay? There are frameworks out there that can help us do this. Selenium, Water from the Ruby languages. Great tools, really good tools, but they rely on you having your application running on a server with the view being complete. They're quality assurance tools. They're not really a development tool, not something we can use in our development practice without large amounts of hardware and a lot of maintenance for somebody to maintain those systems. PHP has PHP Unit, the de facto standard for unit testing on PHP projects. This provides us with a framework for writing simple tests and executing them during development. And by default, we can use this to test Magento. There is no barrier to entry to do this, and you will find examples on the Magento wiki. But we'll run through some code examples. All we actually need to do is to download the PHP unit, install it on our development machine, and create a class that extends the PHP unit framework test case, but we're working with Magento. So in our setup method, we need to initialize the Magento application. All we need to do here is to call Mage app. At that point, we've got the autoloader. We can load in any of the models, helpers. We can execute Magento code from this point forward. So if we want to test our models, again, a new class that extends our test case. We call parent setup, so we initialize Magento. And then we can start to construct our model that we want to test. In this case, we're using the get singleton factory method, which will create a new object which we can test. Okay? So how are we going to start to test that? If we're using rewrites inside of our config XML, we might want to first of all check that we have an object of the right type. That's probably the first thing that's going to go wrong if we're rewriting Magento model or helper. When it's loaded through the factory method, we need to make sure we've loaded the class we wanted. Otherwise, all of the tests will fail. We can check, in this case, that a singleton is indeed a singleton. Every time it's instantiated, it should be the same object. Okay? And finally, we can start to test that our model actually behaves the way we expect it to. We can make assertions through Phpunit to make sure that when we call a method on our object, we get the expected responses. The assertions in this example are part of the Phpunit framework. We can test the type of a response, the value of a response. We can use regular expressions to match. And these are simple lines of code that we can execute repeatedly, time and time again, and make sure that everything we've written is still working. Because although it works today, if we're working as part of a team, do we know it works tomorrow or the week after? If we build up our suite of tests, we can run them repeatedly. They take a few seconds. You get a green light at the bottom of your screen. All's good. We can deploy this code. It's all about building confidence between one release and the next. That was an example of testing models. But what about helpers? Okay, helpers, again, can be tested in isolation. We can write our test classes. Here we've got an example of a setup method. Here the helper actually has a dependency on some data being in the database. Now, if we're testing, we want to make our tests flexible. We want to make sure that they can be used on any project. So inside of our setup method, we're going to create some dependencies, populate the database with some fixtures information so that when we run our tests, when that information comes back, we can respond accordingly. Okay? So here, as we did before, we call parent setup to initialize Magento. We then create our helper with the helper factory. And then we populate the database using standard Magento models, which would equally be tested. We know they work. Gives us a point of failure if they don't, and other tests will pick that up. But at this point, the database is populated. We can start and test. Again, another example. Let's make sure we've got the helper we wanted in the first place, because that's been loaded dynamically through configuration. That may be the first point of failure. But then we can say, does our helper return the data we wanted? In this case, we're retrieving a set of department options. This is an options array for a form control. Does it return the type of data? Does it have the keys that we want? Otherwise, we're going to return a message to the output that says there's been a failure. Okay. So, are we done? Is that cool? We've done unit testing? If you have installed Phpunit through the pair install, it will already be on your include path. Oh. So if you follow the standard Phpunit install, okay, you wouldn't need to include anything. It will all be included for you, but also because we've initialized Magento, the auto-include functionality within Magento will make sure everything's there. But it's not quite time to go home yet, because we haven't really done anything groundbreaking there. Everything you've seen in those slide examples exists on the Magento wiki. Hopefully, some of us in the room are already implementing that type of testing. But it's time to actually look at what we set out to do, because as yet I haven't mentioned functional testing. After all, it was in my opening slide. Okay? There is stuff out there already, such as Zentest. Why don't we just simply use Zentest? Zentest is part of the Zen framework application, which is shipped with Magento. Unfortunately, it's not compatible with the Magento application, because when Magento was designed and built, Zen framework was still in its infancy, and the Zen controller, the Zen application, didn't exist. So there's been a slight divergence between the two projects. Okay? Magento is closely coupled to its Mage core application class. And that close coupling causes inflexibility, Makes it hard for us when we try and provide functional testing tools for Magento. And the key here is dependency injection. This is how we provide flexibility through composition, and in most areas of Magento that's handled through the factory methods of the Mage class. Whenever we want a model, we call Mage get model, Mage helper, Mage get singleton, and they're all configurable through XML. But the application itself is directly coupled to mage.php. So how can we get around this? Okay, some self-promotion here. Mage Test, it's an open source project. Anybody is free to use this. It's on GitHub right now and can be installed safely within Magento and deployed onto production servers without impact. Okay. Mage Test consists of 5 key classes, the first of which is a patched version of Mage Core Model App. Okay? It's only patched. It only has 2 additional methods. All of the functionality is exactly the same as what ships with Magento. We also have a testing request and a testing response fake objects that will be used during testing. And we have some controller test cases and a test case that you saw in my earlier examples that we can use within the Phpunit framework to test Magento. Okay. Mage Core application is loaded from the community code pool because of the prioritized autoloader. So we're not hacking the Magento core. You can safely install this on top of any Magento release, and it will function just as it did the day before. Okay, and deploy it to production hardware. All we're doing here is inside of that class, we've added a set request. It allows us to inject the testing request object, and you'll see below our new method, the existing get request still exists, but because we have the ability to inject reference to a testing fake class, it will be returned when we retrieve it. And the same thing applies to the response. Gives us the ability to inject a response controller so that at the point at which we run the Magento application, we can start to make assertions about the response we get back from the application. Controller tests are handled by controller test case. This mirrors all the functionality of Zen Test. So the documentation online for Zen Test can now be applied to Magento. The documentation within Phpunit can equally be applied to testing Magento. Okay? This gives us the ability to dispatch requests, to make a request for the home page, to capture the response and make assertions against it. So as an example, okay, within the controller test case, we need to bootstrap Magento. Okay? That's what normally happens inside of index.php. And the same things happen here. We're still referencing the server variables to set our Magento install to be running in developer mode. We're still passing in the server variables for our store code and our run code. They can be set manually within your tests, so the Magento continues to function the same way as it always has. The key thing here is that after we've initialized Magento with those variables, we're going to inject with the new methods that we've added to the application the testing response and the testing request. What that gives us is the ability to make fake requests, send them to the controller. The controller will mediate between the model and the view, and it will construct a response object that will be stored inside of our test case to make assertions against. Okay. So here's an example of actually running a test against the home page. Something that you would do repeatedly during development. Check the home page works. Check the contents there that we want. Now, is that a manual task? Something that adds to your working day that you do repeatedly after every code change or before every deployment? Or can we build up a suite of tests where you press one button and you get a green light or a red light? Green light means you're ready to deploy. Red light means you've got a problem, and it's going to tell you where the problem is. You can go and find the problem and fix it and deploy your code. In this example, we're making a dispatch request to the root of our site. That's going to populate the fake request with the URI that we're requesting. That will be dispatched to the controller. Our model will be requested to access the database. The view will be constructed, all of the blocks. And then we can start to say, what actually happened in that request? Was it what we expected? So first of all, the default install of Magento with the default sample data, the home page is a CMS page. So we would expect the root to be mapped to CMS and it to be an index action against an index controller. That's the nature of the CMS module. It has a default index action that forwards to that controller. But what we would expect is some navigation, because a working home page includes navigation to the categories. So we can then query using CSS3 paths to say, on the final line of the for, is there a div in our page with a class of nav container? And if that's true, this test will pass, and we can say that our home page includes the navigation. We could equally do the same with the footer and all other elements that we expect. If we've got a custom design that has different classes, we can write a suitable set of tests to validate that that theme works. So we've only got 5 lines of code there, but what it means is we can say between one release and the next, between one new feature and the next, the home page still does what we thought it should do. Okay. We can dispatch more complex requests. So we could pass in the admin path. What would we expect if we dispatched the admin path? We'd expect that it was the admin HTML root with a login action from the index controller, because you shouldn't be able to hit the admin page without logging in. So we should be asked to log in. So in the next request, we're actually going to validate that we're asked to be logged in because we've got the login form. If the login form is present in the view, we're expecting that we've been denied access, presented a login form. Okay, but what about actually logging in as part of the test? Let's test what happens in the admin suite. Okay, so a request to log in would be indeed a post. We're posting a username and a password. But first of all, let's check that if we try and log in with invalid credentials, we're denied access. Something equally as important, if not more important, than actually logging in. So we're going to build our post array of our username and our password, and we're going to dispatch it to the login request. So we're building a query to the admin module, the index controller, to the login action. Okay? And because we passed an invalid password, we would expect that the response that comes back includes a list of errors. And in fact, one of those errors says that your username and password are incorrect. We can make these types of assertions against the response. We could equally say that the response code is a 301 or a 403 denied access. Okay? And again, building up the suite against our software means that from one day to the next, we're building the confidence in our software. So let's test a valid login, and then actually committing an action after the login. So this time we've submitted a valid admin username and password from the sample data shipped with Magento. We dispatch that request to login, and following that dispatch, we're expecting to be redirected to the dashboard. That's the standard behavior. Okay. But what about committing actions within the admin system? We first of all need to log in and dispatch the username and password, but then to make tests against the admin suite, we're going to call reset. That's resetting the request and response, but our session persists. We still have the same functionality as though it was a browser. Session variables exist, cookies exist. We can then dispatch the next request to say, what happens if we attempt to look at the sales, the orders that we've had in Magento? What would we expect there? We dispatch the request. We would expect a H3 tag with a class of icon head. That's the standard admin theme. And inside of that H3, we'd expect the word orders, because that's what we asked to see. And if we get that response, we know Magento is working. So those are simple requests. But what about testing email? During testing, do we want the emails to be broadcast? If we're running automated tests, we might make hundreds, if not thousands, of requests to different pages and different actions. They may well include checking out as a customer. Where do all those emails go? Okay. A slight addition to our bootstrap inside of our test case. Here, we're going to reconfigure the standard email template class within Magento. That's normally responsible for sending out an email in response to some events within Magento. So if the controller is responsible for placing an order, it would send an email by default. We're reconfiguring that, and then a small hack after that, just to make the config apply. There are reasons for that I won't go into, but that prevents all emails from being broadcast by the system. But we need to equally test the content of those emails. Is that a manual task or an automated task? Well, as we're doing automation, we may as well do that for emails as well. So here, we've got a fairly lengthy test method. But all we're essentially doing is, in this case, submitting the forgotten password form. That should send us an email that gives us our username and password. So, first of all, we're going to retrieve the email content. Because our testing email template no longer sends email, it just holds on to it. It builds the response, captures it, and gives us access. We can set the response body to be that email content. And now we can make assertions against it in the same way we did against a HTTP response. So we can say that because we requested a new password, our email should include in its body the first name and last name of the user that submitted the request. But it should not include, the password, because the nature of Magento's functionality is that it should not include their old password, it should include a new one. So what do those automated tests give us? They give us confidence. As we build a suite of tests, we can be confident between one release and the next, but they can also help us assess the risk of change. If we have code coverage, we can be confident about changing that piece of code because we know the test will pass or fail when we get that code right. If we have no coverage whatsoever and we're going to make a change to the application, who says it works? Us as developers, whilst we're working on it, it may well do. But does it work tomorrow and the day after? It gives us a chance to run static code analysis. Although the two are not dependent, running static code analysis also gives you the opportunity to analyze the impact of functional changes. How difficult will they be to apply? How difficult will they be to maintain? There's a number of PHP tools out there, such as PHP mess detection, PHP copy and paste detection. If you're copying and pasting code between one class and the next, there's generally a reason that that's not a good idea. If you're running static code analysis, it gives you a very good ability to pick these sorts of things up, be it following coding standards within your development team, be it identifying that there's a flaw in the code that you're writing. It gives us the ability to run continuous integration. Continuous integration is the concept of running these tests automatically. So if we're working in a small or even a large team, every time we make a commit, the continuous integration suite will pick up that change and run all the tests that we've written. The developers don't even need to run the tests unless they wish, but we will be alerted as technical team leads, project managers, that there's a problem with the code that's been written. We can identify where that problem exists, when it was committed, when it went wrong. And if we know that things have gone wrong early, it means we can fix them before the 11th hour and before the deadline. Most continuous integration suites will give you lots of feedback. There's a screenshot here from PHP Under Control. This is essentially reading the output of our unit tests and our functional testing. And it lets us get an impression of what our project's doing. Are we slowly building up the unit coverage? Are we increasing confidence in our application? Or are we actually writing code that nobody knows how it works and nobody knows if it's working? And there's a whole range of continuous integration software. We saw PHP under control. We've got part of the Atlassian suite and Jira Bamboo. There's also Hudson and many others. Mage Test and PHP Unit are compatible with all of them, and your output from your tests can be charted and tracked across all the suites. Okay. So what now? Well, as I said, Mage Test. It's open source. It's there for the community. It's there for the community to contribute to. We've built a number of tests that test Magento Core. But the more tests we have for Magento Core as a community, the more confident we can be about building extensions, because we can use the tests for regression testing to make sure that our new code doesn't break the core. Okay? So if we contributed to a project such as this, or others, and had greater coverage of the core, we could all rest easy when we hit the deploy button, we send code to the server, we know it's going to work. Okay, as I say, it's open source, it's on GitHub now. Feel free to fork the project. Quick thank you from me. Those are my contact details. Feel free to use them. I will be tweeting a link to my slides. I'll put them on SlideShare shortly after we've finished. There's also some reference links that, again, I'll include them on SlideShare. Those are all the projects that have constituted either building Mage Test itself, or the tools it can integrate with. Some quick image credits, just because I've borrowed most of my images from Flickr. Any questions?